Greetings, mathletes, and welcome to Unit 9, Part 2, Day 2. Just as a note, your homework is to finish the packet, pages 7 through 13. Also, because this is Day 2, your test will be next class, so make sure that you have your ALEX topics done on time, your pizzazzes are all completed, and your study guide is finished. Alright, so we are jumping into notes on page 7 today. So jump on ahead to page 7 with me. And we're talking about scale drawings and models, and this is actually, I think, the most fun part, because this is the part where, like, architects and engineers and designers and stuff like that, this is what they do. So they do a scale drawing or model, and it represents something in real life, but it makes it smaller so it's easier to manage, and everything in it is proportional. Just like what we've done up to this point, the scale of it is just like the scale factor on the shapes we've been talking about. That is the ratio of the size of the model to its actual size. So, and it's always going to be like that. The scale equals the model over the ratio over the actual. So model over actual. Okay? And it can have the same units or it can have different units. And what you do is you can use ratios to find a missing measure on the model or on the actual object, set up and solve a proportion. You guys remember those. We did those a couple of units back. Piece of cake, easy peasy. You guys are all mathletes. You got this. So let's do the first one together. It says, Eric is planning to build a raised garden. He sketches a plan with a scale of 1.5 inches equals 4 feet. If the garden has a width of 4 inches on the drawing, what will the actual width of the garden be? So our scale, he tells us right here, is 1.5 equals 4 feet. So 1.5 inches equals 4 feet. And it says it has a width of 4 inches on the drawing. So the inches are on the top. So my variable is going to be on the bottom. It's really important that you keep the same things across going the same way, because if you don't, it's not going to work. You're going to end up with something wonky. So then we cross multiply. 1.5 times x equals 4 times 4. Then we solve it just like we did before. 4 times 4 is 16. That's still 1.5x. Divide both of those by 1.5. Grab my handy dandy calculator. 16 divided by 1.5. Oh, I don't know what that equals, so we'll switch it over to my phone. My calculator was working and now it's not. So we're going to take 16 divided by 1.5, and that gives me 10.6 repeating. So it's 10.6 repeating feet is how far that is. Now, if you could leave it like this, but let's think about that for a minute. It's 10 feet, and 0.6 is 2/3. 2/3 of a foot is 2/3 of 12. Well, 1/3 of 12 is 4. So you could also say it is 10 feet and 8 inches. Both of those answers are correct. If you leave it as this one, that's totally fine. Okay, but I just also wanted to point out that if you converted that 0.6 repeating to a fraction, you could take it to inches and do it either way. Okay? So those are scale drawings and models, pretty straightforward. But what if they give you the model height and the actual height and you have to find the scale. Just like we talked about a second ago, it's always model over actual, and this tells me it's 6 inches over 72 feet. So I'm going to simplify that, and to simplify that, I know 6 will go into both. So I'm going to have 1 inch equals 6 into 72 goes 12 times. So that means for every inch on the model, it's 12 feet in real life. Okay? Indirect measurement. We did these also back when we did proportions. Indirect measurement uses the properties of similar triangles to find the measurements that are difficult to measure directly. And one type that's used commonly involves shadows. Remember we did those back when we did proportions? We had a person who made a shadow and a building who made a shadow, and how tall is the building? Oh, look, we got one of those right here. And there's a little sample proportion off to the side to help you keep it straight. And you know me, I always draw pictures to figure these things out. So the problem says we have a home. It casts an 85-foot shadow, and at the same time a bush casts a 10-foot shadow. If the bush is 6 feet tall, how tall is the house? So we have a house and a shadow, and a bush and a shadow. The home casts an 85-foot shadow. The bush casts a 10-foot shadow. And it says the bush is 6 feet tall, and it wants to know how tall is the house. So now we're going to use this little box to the side, and we're going to put height over shadow, x over 85 equals 6 over 10. And then we're going to bust out the handy dandy calculator again. And we're going to say that 10x equals 6 times 85. Drop my line, so 10x equals 6 times 85, 510. And I know that when I divide by 10, it's just like moving the decimal point one place to the left. So that means x equals 51, so the house is 51 feet tall. Okay, hopefully this is all review. Again, this is all stuff we have done before in proportions. The proportions unit, which I can't remember if that was unit 7 or unit 6. But that's it. That's all we've got for today. So make sure you get your packet pages done. Make sure you get your study guide done. Make sure you have your Alex topics done. Your test is next class. So yeah, get ready. Have a great day. Bye.